Hello students, in this video I will discuss about physical pendulum. Suppose we have a bottle like this. This is the position of its center of gravity and this body is pivoted at this point, suppose O. Now we can say in equilibrium this line should be vertical, so no torque will be acting on the body. Now suppose I displace this body like this, then the center of gravity point will shift to this new point, right? And we will observe that the body will be performing SHM like this about the axis. So let's draw the diagram again. After displacing the body looks like this. This is the center of gravity, right? This is the pivot point O, and if you observe carefully, the axis is like this. This is the axis, right? And this axis is perpendicular to the plane of this page. Now the body is displaced from the initial line by this angle theta. We will assume that this theta is very small, so theta is very small. Therefore the applied torque to displace this body from the initial position to this position is the rotation is like this, right? Now in this position weight will act in vertically downward direction like this, and it will act from center of gravity. And let us assume that this distance, the distance from the center of gravity from this point, pivot point, is L. Okay. Now what are the forces acting on this body? First force is weight, which is acting vertically downwards. Another force is acting like in this line, and another force will act at the point of pivot. But if we take the restoring torque, why it is restoring? Because see, the applied torque rotates the body like this, and this torque due to mg will try to rotate the body in the opposite direction, right? So this is restoring torque. Restoring torque will be entirely due to mg, because all other forces acting on the body will pass through point of pivot. So the torque is minus mg into perpendicular distance. Now what is the perpendicular distance? This would be the perpendicular distance of the line of action of mg from O. So this perpendicular distance is very easy to calculate. It will be L sine theta. So torque will be mg into L sine theta. Now I consider that theta to be very small, therefore I can write tau equals to minus mg L theta, since theta is very small. Now for angular SHM, we know that tau must be proportional to theta, right? This is the condition for angular SHM. Now look at the expression we got here. Tau equals to minus mg L theta. So clearly the body will perform SHM. Tau, now tau is nothing but I alpha. I is, remember this I, be very careful, I is the moment of inertia of the body about the axis of rotation. Now the axis of rotation for this body, this is the body, this is center of gravity, and this is the point of pivot. Therefore we have to calculate its moment of inertia about this axis, right? About this axis. Now we will come to that later. Alpha is what? Minus mg L by I into theta, and we know alpha equals to minus omega square theta. So comparing, we can write omega square equals to mgl divided by I. So omega equals to root over mgl divided by I. Therefore time period of oscillation is nothing but 2 pi by omega. So 2 pi root over I by mgl, right? So this is the general formula of time period. T equals to 2 pi root over I by mgl. Now I will come to each and every part. Now what is I? I is the moment of inertia of the body about the axis of rotation, and we know from parallel axis theorem that if the moment of inertia of the body about an axis passing through its center of mass or center of gravity is I c, and L is the distance between that two axes, then you can write I equals to IC plus ml square, right? Where m is the total mass of the body. And if radius of gyration of the body about an axis passing through its center of mass is k, I can write IC as mk square plus ml square, right? Now don't forget what is k. K is the radius of gyration of the body about an axis passing through its CG, right? So I equals to mk square plus ml square. Let me put the values there in this equation. T equals to 2 pi root over I by mgl. So I is mk square plus ml square divided by mgl. This is nothing but k square by L plus L divided by G. Therefore we can call this quantity as the L effective for physical pendulum. Therefore T equals to 2 pi into root over L effective divided by G. And that is the formula, where L effective equals to L plus k square divided by L. Again I will emphasize on the fact that what is L? L is the distance of the center of gravity or center of mass of the body from the pivot point. And what is K? K is the moment of inertia of the body about an axis passing through its center of mass. Okay. Now see, I can tell you that for a normal simple pendulum, we take a bob of point mass, right? Point mass, and the string is massless. Therefore I can say this is the bob, right? The bob has a mass of m and the string is massless for a simple pendulum. Now the distance of the pivot point from the center of gravity is L. So L is L here. Now what is K? K is the moment of inertia of this bob. K is the moment of inertia of this bob about its center of gravity. Now since this bob is a point mass, therefore I can say for a simple pendulum K will be 0. Now L effective will be simply L plus 0 divided by L, which is L. So for a simple pendulum, time period formula would be simple 2 pi root over L by G. Therefore I can say simple pendulum is a special case of physical pendulum, right? Or physical pendulum is a generalized case for a simple pendulum. I hope you understand. Okay, now coming to next point. If you are asked to find the condition for which T will be maximum and the condition for which T will be minimum, let me come to that. Now case 1, for T to be maximum, look at the formula carefully. T is 2 pi root over L effective. L effective is what? L plus K square by L divided by G, right? So for T to be maximum, we can say this L effective should also be maximum. Now when does this value will maximize? It is very clear that this value will maximize if L tends to 0 or L becomes 0. So if L becomes 0, L effective becomes infinite, right? Therefore T max is also infinity. Now what is the meaning of actually L equals to 0? That means the pivot point should be the CG of the body. That means the body should be pivoted from its center of gravity. Like see, if we have a disc, if we have a disc like this, and this is the center of gravity point now, and you pivot here at its center of gravity. So in this condition, if we just move this disc slightly towards any direction, then it will remain in that direction. Therefore I can say the disc will not perform any kind of SHM. Now if it doesn't perform any kind of SHM, I can say its time period must be infinity. That means it will take infinite time to reach back to its previous equilibrium position. It will never return, right? So time period is infinite. I hope it is clear. Coming to case 2. Case 2 is important. Here they will ask you the condition for which T, that is time period, will be minimum. I will again write the formula. T is 2 pi root over L effective by G. L effective is L plus K square by L into by G. Now for T to be minimum, this effective length, L effective, must be minimum, right? Now L effective is L plus K square by L. To find the minimum value of this, we will differentiate it. We will differentiate it with respect to L. So dL effective divided dL is 1 plus K square into 1 minus L square, right? And from the concept of maxima and minima, we know that at minima or maximum value, this first derivative thing will be equal to 0, and from that I can say this K square by L square must be equals to 1, so k equals to L. Now this is the condition for T minimum. Now why minimum? You can always take double derivative d to L effective dl square, which will be TTL of 1 minus k square by L square, which is k square into 2k square by L cube, which is positive. Therefore, at k equals to L, I can say the L effective will be minimum, right? At k equals to L, L effective will be minimum, so T will also be minimum, right student? Therefore, I can say what will be the minimum value of T? It would be minimum when L equals to K, right? L equals to K. So I put K here in place of L. So K square by K divided by G. So T minimum is 2 pi root over 2K by G. Now this is the formula for T minimum. Okay. So let me revise the entire thing for you again. See, for any physical pendulum like this is the pivot point, this is the center of gravity, the distance between these two points is L, right? And radius of gyration of the body about an axis passing through its center of gravity and perpendicular to the plane is K. Okay, this is the radius of gyration. So I can say the ICOM is mk square, right? Then the time period will become 2 pi root over L effective by G, where L effective is L plus k square by L. Okay, T maximum would be equals to infinite when L is equal to 0, and T minimum would be 2 pi root over 2k by G when L equals to K, right? Now let us do some problems. Now for first problem, you are given a disk. This is a disk of mass m, say, and it is pivoted here at a distance r by 2 from its center of gravity, right? The radius of the disk is r. You need to find its time period. So this is a very simple question. Now here L is the distance between O and CG, is clearly r by 2. Now we need to find K. K is the radius of gyration of the disk about an axis passing through its CG. So I can write mk square equals to half mr square for a disk, we all know. So K equals to r over root 2, right? Therefore L effective is simply r by 2 plus k square by L. So k square is r square by 2. Okay, so this is r by 2, so simply 3r by 2, right? Therefore time period would be 2 pi root over L effective by G, that is 3r by 2G. Now that's the answer for this question. Clear? Now coming to our next example 2, you are given a disk. This is its center of gravity. Now the disk is pivoted here at O. This distance is given as L. They ask you for what value of L time period would be maximum and time period would be minimum. Also find those values of time period T max and T min. Clear? So coming to the solution, for T max, I've already told T max is always infinity when L equals to 0. That means the disk is pivoted at its center of gravity. Now for T minimum, so T minimum is very easy. T minimum, as I mentioned, 2 pi root over 2k by g. Now what is k? K for disk, as mentioned in the last question, it is r by root 2, right? R by root 2, put here 2 into r by root 2 by g. So this is 2 pi root over root 2 r by g. This is the minimum value of time period, right student? And when that will happen, when L equals to k, right? And k we all know r by root 2. So these are the answers to this question. I hope you understand this. Clear? Now coming to third example. This is also a very good example. 3. Understand this problem very carefully. You are given a string like this, and from this string a bob is suspended. The mass of the bob, this is the bob, okay, the mass of the bob is m bob, and the mass of the string, this is not a massless string, the mass of the string, I can say rod, is also m, same as the bob. The length is L, not small l. Let the length of the rod is x, okay, length of the rod is x. Okay, now they ask you find the time period. Now in this kind of questions I always suggest you to use the basic formula. The basic formula is, let me take you to that. The basic formula is simple, this 2 pi root over I by mgl, 2 pi root over I by mgl, right? Where I is the moment of inertia of the body about the axis of rotation, m is the total mass, g is g, and L is the distance between the center of gravity and the point of suspension. I will ask you to use this question, and later I will also use our general formula in this question too. So if I use the basic formula, T equals to 2 pi root over I by mgl, right? Where I, this is the pivot point, na? This is the pivot point O. Now for I can say I is the moment of inertia of this system about point O. Now for the bob, the moment of inertia is very simple, which is mx square. This is for the bob, right? And for the rod, it is, we all know, for a rod the moment of inertia is, this is not the moment of inertia, this is not a string, you can say mass of the rod, because in case of string some other problems may arise. So for the rod, we know if the rod is rotated about an axis passing to its one end, then its moment of inertia is 1/3 mx square, right? So this is for the rod. So I equals to 4/3 mx square. Clear? This is the value of I. Now here, so I is this thing for m, coming to m. Now m, see, m is not m, m is basically m plus m, that is twice m. Why? Because the rod as well as the bob both are performing SHM. Now for length, this is important. L is the distance of center of mass of the system from the pivot point, right? Now we have to calculate the center of mass, position of center of mass. For the rod, I can say the center of mass is situated exactly at the middle, and for the bob is very small, center of mass situated here. So I can say the rod is uniform, so the center of mass of the compound system must lie here, right, at a distance what, L by 4. So this distance is also, so not L by 4, it is x by 4. This distance is x by 2, therefore I can say L is x by 2 plus x by 4, 3x by 4, right? So let me put all the values to find t equals to 2 pi root over I is 4 by 3 mx square, mass is twice m, g is g, L is 3x by 4, so it would become 2 pi root over 8, I believe, 8 into 2, 2 into 4, 8 will cancel out, 8x by 3 into 3, 9g. That's the answer to this question. Now many students ask me, sir, why don't you use the L effective formula? You can also use L effective formula, but then if you use that formula you can face some difficulty. But if you are sharp in calculation, then that formula is also suffice to solve this problem. Let me solve this problem, or let me find this answer by using that method. Okay, let's see if we get the same result or not. So for that, this is the bob, right? This is x, mass is m, and that formula says T equals to 2 pi root over L effective by G. L effective is L plus k square by L. Now see, what is L? L is the distance of the center of mass of the system from the pivot point. This is pivot point, and as I mentioned earlier, the center of mass of the system will be situated here. So the L length is nothing but this length, which is 3x by 4, right? So L is simple 3x by 4. Okay, now K is what? The radius of gyration of the system about an axis which is passing through its center of mass. So about this axis, let me find the moment of inertia of this system about this axis. Okay, let me first find that. So I equals to what? For the bob it will be simple, m into x by 4 square, right? This is for the bob, plus for the rod we know ICOM is this, ICOM is what? 1 by 12 m x square, right, plus md square, where d is this distance, that is x by 4 again. If we do that, it will be mx square by 16 by 8 plus 1 by 12 mx square, which is 24, what is that, 5 mx square by 24, right? Now see, what is I I is, I can be written like this: total mass into k square, right? We all know from the definition of radius of gyration. So k square will be 5 x square by 48, right student? Therefore L effective would become L plus k square by L. L is 3x by 4 plus k square is 5x square by 48 by L, that is 3x by 4. So become 36 LCM, 27 plus 5, that is 32 by 36 into x, right? That is 8 by 9x. Therefore simple time period would be 2 pi root over L effective, that is 8x by 9g. And you can see same result get here also. So this is the answer. I hope after seeing this video you will not face any problem regarding physical pendulum. Thank you for watching this video. Please subscribe my channel, Phi Solver.